Okay, so for today, we're going to be talking about graphing circles on a coordinate plane. Because remember, we've talked about all of our shapes on a plane, coordinate plane, and then off it. And so this is where we bring this to a graph and say, let's talk about the ordered pairs that form this. And so, we've talked about shapes in this class. We're like, oh, let's graph, say, a line. And, if you had like y is equal to 2x plus 1, you know number one, you can graph it, okay? You can do y equals mx plus b, where you begin at the y-intercept and then you apply the slope. You also know that there are a lot of points on that graph, and you can start listing out some of the ordered pairs that make it true. So like you could plug in, say, x is 0, and figure out the y that goes with it, the xy team that makes it true. You would do 2 times 0 and add 1. So 2 times 0 is 0, and then you'd add 1. And that would give you 1. So the point 0, 1 would be absolutely a point on this graph. And to graph it, you'd start at the y-intercept, which is this value. And then the slope is a positive. So you'd go the rise over the run, you'd go up 2 and right 1. But also, and down 2 and over 1. You can come up with another point. Plug in x is 1. 2 times 1 is 2. Add 1, you get 3. So 1, 3, when x is 1 and y is 3, that will make this true. And you can demonstrate that by trying it. You're like, okay, if y is equal to 2 times x, and if x is 1, and you add 1 from the formula, what are we going to get for y? Well, we're going to get 3. So there's a lot of points. In fact, there's infinitely many points, and all of them fall on this line that make that equation true. We don't have to find them all. We can't. It would take forever, and we'd still not be done. So cure cancer, don't do that. But you can certainly come up with a couple ordered pairs that make it true, and you can also put a visual to the points that do make it true. Another thing we've spoken of this year, and you did more of it last year, was graphing parabolas, where we said, okay, to graph a parabola, it's like y equals like x squared plus 1. And you could make a table of values to make that true as well, and I'll switch colors. If you wanted to graph that, it's a parabola. The plus 1 is going to bring up that parabola by 1 square from the origin. It's normally at the origin, but if it has plus 1, it's up 1. So you can try plugging in x is 0. X squared is 0. Plus 1 gives us 1. So that's one of the points. And you could plug and say 1. 1 squared is 1. You add 1, you get 2. So 1 is 2. If you plug in negative 1, negative 1 squared is 1. Plus 1 is going to be 2 as well. You can see the formation of a parabola that's going to be up 1 square from the origin. And you're going to be graphing a lot next year where we say, hey, the parent of this function is a line, and then talk about how you graph it. The parent of this is a parabola, and then there's transformations or things that change it to say, okay, it deviates by moving it up 1. And so today we're going to be talking about graphing circles, and again, it has x and y. The weird thing about it is it's not like y equals, like on both of these, you'd see it's y equals with x's, y equals with x's. This one is going to be shown like this. It's going to say like x squared plus y squared equals a number, which is secretly squared. It's secretly the Pythagorean theorem in disguise, doing all sorts of crazy things. And we'll talk about that maybe a little bit, okay? And so you're like, well, how in the world would I make a table of values that would make that true? And how would I know what it looks like? Well, you can like use your mathematical like wisdom and be like, okay, let's try it, And I think my secret for you would be like, you can try plugging in x or y that's 0, and try that. And so, think about this. If x is 0, what would y have to be to make that true? You could do like 0 squared plus something squared gives you 25. Can you tell what y would have to be to make that true? Well, it would have to be 5, because 0 squared plus 5 squared does equal 25. So a 0.05 is going to make this true. And so let's think about what else we could come up with that would make it true. And in class today, I'm going to have people try. And I think, people look at this and be like, that's kind of hard. But later in the day, I bet you there's going to be some people who say, as they're awake, to think about like, what could you come up with? Well, is there a rule? We just need a team that makes it true. Is there a rule that you can't say that y is 0? Well, what if y is 0? You would say some x being something plus 0 squared gives us 25. Well, that means that x is going to be 5 as well, because 5 squared plus 0 makes 25. So 0, 5 is a point. I missed that one there. Let's go down one right here. 5. And then this one is 5 here. Okay, but think about another thing. What if x was negative 5? What would you get? Well, if x is negative 5, negative 5 squared also is 25. So that's another point, negative 5, 0. If x was negative 5 squared, that's 25 plus 0 will also give us 25. And that means also that probably 0, negative 5 will work. Try it. If x is 0, 0 squared plus negative 5 squared, that's 25. That equals 25. Now, if you get really creative, okay, there are actually some numbers other than 5s and 0s that will actually work. What do you mean, woman? Well, what if x is 2 and y is 3? What do you mean? Let's just see if that works. No, that doesn't work. Oh, it's going to be 3 and 4. Okay, let's fix that. Let's reroute this. If x is 3 and y is 4, what do you mean? What's 3 squared plus 4 squared? 3 squared is 9. What's 4 squared? 16. Does that equal 25? Yeah. The point 3 and out 4 actually works. You can tell that we're building a circle. There are infinitely many points on this. All of them are 5 hops away from the origin, the center of this circle. And there's a lot of points that make it true. And I picked this equation because you might be able to see some of the ordered pairs that could make it true, maybe come up with it. But that's not how we want to graph it. We want to say, hey, when I see x squared plus y squared equals a number, that will graph like a circle. Just like when you see a line, you're like, oh, that's a line. Ooh, this is a parabola. Knowing the parent function and then saying, okay, if it's a circle or if it's a line, this is how I'm going to graph this specific line. And I want you to look at this and say, okay, x squared and y squared equal a number. That number is going to be related to the radius, isn't it? It's equal to the radius squared. And so the parent function of this graph is going to be x squared plus y squared equals the radius squared. And that's based upon the Pythagorean theorem because anywhere you go in a circle, the radius squared is equal to the x value and the y value squared and added up. The radius is the same all the way around the circle. If you add the x coordinate squared plus the y coordinate squared, you'll get the radius squared. And so, and again, I'm not going to ask you that, but I want you to see that our formulas sometimes have more to them than what you'd appear. Just like when we talk about lines, we talk about the beginning value, the y-intercept, and the rate of change. If it's positive or negative, that's how fast it's increasing or decreasing. And so as we're graphing these circles, yeah, this is the parent right here. X squared plus y squared equals radius squared. But then what we can do is we can do transformations. Just like you do with lines, the one over here raises or lowers it. The slope changes depending if it's going uphill or downhill and how fast the slope is. Now, on a circle, the two main things we're going to change would be how big is the radius and where is the center. And so, although this is the parent, this is going to be how you transform it. H and K are going to be the center, horizontal and vertical. They don't do V because the V of a vertex is like a parabola. So it's horizontal and vertical. So H and K. And then the radius. So we can control the center, which is H and K, and then the radius. Now you see there's some subtraction signs in this formula, and that's okay. That means two things. Number one, when you put it in there, you're going to do x subtract, and then you're going to put the h value. then you're going to do y subtract, and then you're going to do the k value. It has to do with the distance formula. It has to do with how far away it is, but that's how you plug in. So if you get minus and negative, it's fine. It becomes plus and positive. The other thing you'll notice is that because it's the Pythagorean theorem, you square the radius to put it on the right side. And if you see a number there, that's not the radius, that's the radius squared. So those are two things that you need to hold on to. So let's look down here. It says, can you write the equation of a circle, okay, who has a radius of 5 and a center at negative 3, 4? And so here's kind of where it gets a little spicy. And what we can do is we can say, if this is the transformation formula, okay, the parent is x squared plus y squared equals the radius squared. And again, the two things we're going to change would be the center and the length of the radius. So we're going to go x minus, and because the radius is a negative 3, we're going to plug in negative 3, and we're going to square it. I should change back to blue, but okay. And then plus y minus, and the y coordinate is, that's x, that's y, 4, and then squared equals the radius squared, 5 squared. So you would get, when you reduce it, you get x plus 3 squared, y minus 4 squared equals 25. This is the equation of a circle whose center, and you can kind of see it, you got to be a bit of a spy, is that the center is basically the opposite of each. So it's negative 3 and 4. Okay, that's the center. And the radius equals 5. So I think those would be the main principles is, can you take an ordered pair and plug it into the formula? Can you take a radius, remember it equals radius squared? Or can you look at an equation and say, I can tell what the center is and I can tell the radius is going to be 5. So you kind of have to be a spy to remember how to plug it in and then also how to read it once it's there. We can try the next one where it says the center is at 2, negative 5, so it's x and y. Let's do x minus, and then the value of x is going to be 2, and it's squared, plus y minus a negative 5, so we have plus 5 squared equals the radius squared. So you've got to take the square root of 17 and square it. So what would we really write? The square and the square root undo each other, so we'd really write 17 here. And so if you're reading this picture and saying, okay, let's look at it, the center of our circle would be at 2 and negative 5. Because putting into the formula, you've got to remember it's x subtract each of the h and the k. And so when you're reading it, you've got to say, I'm going to do the opposite of both x and y to get the center. And so we're going to move forward. Kind of feel like we should do the picture first, and then we'll go back and do number 3. So let's do the picture first. So in the picture, what's the center? It's at negative 3, 1. So can we write the equation that does this? So let's do, that's x, and this is y. Let's do x minus the negative 3, so plus 3 squared plus y minus 1 squared equals the radius squared. Well, how big is the radius? Well, let's count some squares. 1, 2, 3. All right, so we're going to do 3 squared. Okay, let's write that as 9. Okay, so when you're reading it, the center would be at negative 3, 1, and it is, and the radius would be 3. And so notice from the center, you can go 3 in all the directions. And it's easiest to go east and west and north and south, and then plot those points and connect them if you're graphing it. This question number 3 has got a little salt to it. Okay, and so the center for h and k is right here. And instead of giving us the radius, they tell us a point on the circle. They're like, well, that's really mean. And we can do a visual of it. And we're like, okay, the center is at 1, negative 4. Right here. And then it goes through 1, 2, 3, 4, 5, negative 1. So that means if this is the center and it goes through here, it's going to be about this big. And so we know the center, but what we don't know is the radius length. Okay, and so to find the length between any 2 points, we can use the distance formula. And so if we're going to start the formula, we could say x minus 1 squared plus y minus negative 4 or plus 4 squared equals the radius squared. We've got to wait for the radius squared. Okay, let's find that. So how do you find it? Well, distance formula. And so the distance formula, we haven't used that in a while. We want to find the distance between here and here. We're going to say, and it looks a lot like a circle formula, so don't lose your mind, because the basis of the circle is that every point on the circle is the same distance from the center. So that's why it feels like the distance formula. Okay, so to find the distance between these 2 points, remember the distance formula is equal to the square root of x2 minus x1 squared, or you can do x1 minus x2, it doesn't matter, and then y2 minus y1 squared. And then you add those up in the square root. Again, the distance formula is the Pythagorean theorem. You're like, everything's a Pythagorean. Yes, lots of things in life are based upon the distance. And so when we do the distance formula, we're going to subtract the 2 x's and subtract the 2 y's, add them up, or then square them, and then add them up, and then take their square roots. So let's try. Let's do x minus x. Let's do 5 minus 1. 5 minus 1 squared, and y minus 1, so that's going to be negative 1 minus a negative 4, so plus 4 squared. So you're going to take the 2 x's, the first points, okay, 5 minus 1, take the 2 y's, negative 1, subtract a negative 4 squared. So this will be 4 squared, which is 16. This would be negative 1 and 4 is 3. 3 squared is 9. Add those up. 16 plus 9 is going to be 25. I'm going to take their square root, and we'll get the radius equals 5. So the length here is 5. And that looks like it's true, doesn't it? I mean, if you look at it, like if the answer was like 75, you'd be like, okay, we done mess up. The length of this could be 5 units across. So what do we put here? Not 5, we put 25. Because the formula says x minus the h value squared plus y minus the y coordinate k squared equals the radius squared. So when we look at this, our circle should have a center at 1, negative 4. 1, positive, I'm sorry, that should be positive. 1, negative 4, and it does. And the radius equals 5. So knowing the code to how to read an equation, knowing how to put values into the equation, those are going to be good. And the more you know about transformations and about what we're working with, the better it's going to be. And so let's practice reading them right now. So given this formula, we're like, hey, it's a circle because I loosely see the x squared plus y squared equaling a radius squared. But the center is not at the origin. Because it's been dragged right and left and up and down, you're going to say that the center is not at the origin. Okay, if you just saw x squared plus y squared equals radius squared, the center would be at 0, 0. But because you see adding and subtraction to the x and the y, the x moves it horizontally and the y moves it vertically. So what is the center? The opposite of each. So it'd be 1 and negative 2. And what would be the radius? Not 36, it is 6. Okay, so 6 units. So how do you graph this? Well, go to the new center, 1, negative 2, make a dot there, and then we go 6 units in as many directions as you want to go. It's harder to go slanty, so normally you count up 6. 1, 2, don't count the original, so count up 1, 2, 3, 4, 5, 6. Count to the right. How many steps you move from the origin, or from the center? So go 1, count 1, 2, 3, 4, 5. I can't count. 1, 2, 3, 4, 5, 6. This one here. And then count 6. 1, 2, 3, 4, 5, 6. And then go left the same amount. 1, 2, 3, 4, 5, 6. There we go. And then you draw a circle. Most of mine look like dead fruit. Okay, but go with your best thought. And that's why we physically write them. The center is here. Okay, and the radius is 6. And so knowing that the x and y value shoves it left and right, and that the radius is as shown. Okay, if we were in class, I'd say, okay, try the next one, see if you can get it right. What would it be the center? The x would be negative 4, and the y would be positive 1. That's our new center. negative 4, 1. That's h and k, horizontal and vertical. The radius, remember it's x squared plus y squared equals radius squared. And so the radius is actually 4. And so go up 4. 1, 2, 3, 4. Go right 4. 1, 2, 3, 4. And down 4. And up 4. Draw your circle. And you're good to go. Okay, your center should be as shown, and your radius will be the square root of that number on the right. Okay, here we go. Normally, if it was x squared plus y squared equals, say, 16, our origin would be our center, and our radius would be what number? It'd be 4. Okay, it would look like this, if that was assuming you go forward each direction. And so only when it's added or subtracted from the x and or y that you get it dragged in a different direction, okay? And so what would be the center here? Well, it doesn't get dragged any direction for x, so that would be 0. However, the y gets moved, and so you do the opposite, so 0, 2. And then your radius is 5. So from this point, go right 5, go up 5. I'm going to just add, so it's 2 up plus 5 is 7. And then down here would be negative 3. Yep, and then 1. And so let's do this here. 5. Make sure your radius is 5. Count 5 in each direction, and then draw your circle. And then look at it and see, does it make sense? Is it a circle? Yes. Does the radius match the square root of the right-hand number? And is it drug from the origin, how much the x and how much the y, but opposite of what you see? So I want to go back to the original form now. When you're plugging in points, remember you're doing x subtract, and you put the h value, plus y subtract the k value. Both of those, and then equals the radius squared. And so can you plug in things, and then from an equation, can you see the h and k, the new center, okay, if it's been drug from the origin, okay, if there's nothing added or subtracted to either x or y, it's going to be at the origin. And then can you see the length of the radius looking at the number on the right-hand side? Thank you so much. Have a good day.